Hello everyone, this is Deepak Kumar, Assistant Professor in Kite Group of Institution. In today's session, we will discuss the implementation of queues using linked list. So we know that these are the major operations of queue, that is enqueue, dequeue, display and finding the peak element of the queue. Now we will discuss all these operations with the concept of linked list. Okay, so the prerequisition for this video is the linked list concept. So kindly go through with my list video, then you will easily understand the concept of linked list. So now we will start with the very first operation, that is enqueue operation, that is known as insertion. So when we want to perform insertion in linked list, so first of all the nodes structure should be very clear. So we just create a node, struct node, having two field. The first one is the data field and the next one is the pointer field, that pointing to the next element of the list, that is next node. So here the return type is struct node pointer. In general case of linked list, we generally use struct node pointer start. Start variable is pointing to the very first node. But when we represent queue as a linked list, then we choose two variables. The first one is the front and the next one is the rear. And initially the value of this front variable and rear variable is equal to null. Okay, and these two variables of struct node pointer type variable. Okay, because these front and rear variable is pointing to a particular node. Okay, so why we use front and rear? Because we know that in linked list, insertion and deletion is performed from two different ends. Okay, so what is the difference between linked list and array? Actually, in array, the static memory allocation is used. Okay, so let's suppose if initially you allocate the size of the queue as 100, and after that you just store only 20 values. So here there are lot of wastage of memory. Okay, so we generally use the concept of linked list that uses dynamic memory allocation, so that the wastage of memory will be reduced. Okay, so when we want to perform enqueue operation, so we generally use this function void enqueue, and we want to insert the element, and that element is X. So what we do when we want to perform insertion in queue using linked list, so first of all a temp variable is defined, that is struct node pointer temp, that is pointing to a particular node. Let's suppose this temp is pointing to this particular node. So first of all this temp variable is declared, and then dynamic memory allocation will be performed with the help of malloc function. When the dynamic memory allocation will be performed, then this node will be constructed. Then we provide the value of this node, that is temp to data, data is 10, and temp to next is equal to null. Okay, then we check that if front equal to null and rear equal to null, this condition is basically used for checking that the queue using linked list is empty or not. Okay, if this condition is true, that means your list is empty, and this is your first element. So front is equal to rear equal to 10. Now front and rear both pointing to this very first node. Okay, now again let's suppose if you want to insert another element, that is 20. So Again, we just first of all, this temp variable is declared, that is struct node pointer temp, and now temp value is 2000 because temp pointing to the another node having value 20. So temp to data is 20 and temp to next is equal to null, and temp is equal to 2000. Okay, because temp is pointing to this node. So now the value of temp is 2000. Okay, we check that if front equal to null and rear equal to null. No, right now this condition is false because front and rear both pointing to this particular node. Now we just move toward this else block, that is rear to next is equal to temp. Rear to next, so rear is what? Front and rear both pointing to this particular node. So what is the value of rear? The value of rear is 1000. So rear to next is what? Rear to next is null initially because the very first node is null initially. So rear to next value is replaced by temp, that is 2000. So rear to next is 2000. When it is 2000, then it will point to this particular node. Okay. So this is the way through which we perform insertion. In the same way, let's suppose we want to insert 30. So what we do, again took temp variable, and now this temp value will contain 30. Okay, and rear to next will be replaced by 10, that is 3000. Okay, so this is the way through which these three elements will be inserted. So let's suppose if we have the scenario, we have already 3 elements available in our linked list, and we want to insert another element, that is 40. Okay, so again this temp value get declared, and temp is pointing to this particular node. So the dynamic memory allocation will be performed, data and next field will be filled. Okay, and the value of temp is 4000. So we check if front equal to null and rear equal to null. So right now front and rear is not equal to null because front is pointing to this particular node and rear is pointing to this last node. When we want to insert this particular node over here, so what we do, we just increase the value of rear, that is rear to next is equal to temp. So rear to next is currently null. Now it is replaced by temp, that is 4000. So when it is replaced by 4000, then this will automatically connected with this particular node. Okay, and what we do, we just increase the value of temp, that is rear is equal to temp. So now what is the value of rear? Rear is equal to temp, that is rear is equal to 4000. Now rear is pointing to this particular node. Okay, so actually when you want to perform insertion in general case of linked list, so you cannot directly perform insertion over here because in that particular case we don't have rear variable, we have only start variable that pointing to the very first node. Okay, so in that particular case we just choose another variable, pointer type variable p, and initially the value of p is equal to start, and then p is equal to p2 next. Okay, and then finally we will reach to this particular location, and then we will insert a new node over here. So in general case of linked list, the complexity is O n, while in the case of queue concept where we manage two variable, front and rear variable, so in this particular case the complexity is order of 1 in the case of insertion. Okay, now we will move towards the next operation, that is dequeue operation. So again this is the structure of a node. Let's suppose we have 3 nodes available in linked list, and we want to perform dequeue operations. So we know that when we are using queue, then the dequeue operation will always perform from front end. Okay, so what we do, first of all we just took a temporary variable temp having struct node pointer type, and initially the value of temp is equal to front. Okay, so now we just took this temp variable, and initially the value of temp is what? Initially the value of temp is front, that is 1000. So now when temp is 1000, that means temp is temporarily pointing to this particular memory location. Initially we check if front equal to null and rear equal to null. No, this condition is false because the list is not empty. Then we check front is equal to rear. So here this condition is also false because front is pointing to this node and rear is pointing to this node. So value of front is 1000 and the value of rear is 3000. When this condition is true, front is equal to rear, when in the list we have only one node. So when we have only one node, then front is equal to rear. But here we have three nodes, so right now the front and rear value is not equal. So this condition is false. Now we will move towards this else block. That is front is equal to front to next. So front is what? Front is 1000. Now what is the value of front? The value of front is front to next. Front to next is what? 2000. So that means front is pointing to this particular memory location. Okay. So when this front is pointing to this particular memory location, so now we can free this particular node. Okay. So for this operation we generally use this free function, and actually we just want to free this particular node, and this node is pointed by temp, so we generally use free temp. Okay, so this node will be freed and deallocated from the memory. So this is the way through which we can implement dequeue operation in queue. The next one is the display operation. So if we want to display the element, if we want to display the node of a list, so how it will be identified? First of all, we just took a temporary variable temp again, and initially the value of temp is equal to front. Okay, we check that is front equal to null or rear equal to null, because if this condition is true, that means the queue is empty. We cannot display any element. Else, while temp not equal to null. So if temp is equal to front initially, while temp not equal to null, printf temp to data. So temp to data is what? Temp to data is 10. So this 10 will be printed, okay, over this sign, because this sign is used in printf. Then temp is equal to temp to next. So what is the value of temp? Temp is equal to temp to next. Temp to next is 2000. So now temp is pointing to this particular memory location, and the value of temp is 2000. Okay. Now again we check temp is not equal to null. Yes, the condition is true. Then temp to data. Temp to data is what? That is 20. Okay. Now this 20 will be printed. Again temp is equal to temp to next. So now the value of temp is 3000. And temp is pointing to this particular memory location. Again we check temp is null. No, temp is not equal to null. So again we print the data, that is 30. Okay, and temp is equal to temp to next. So temp to next is what? Null. Again we check temp is not equal to null, but right now temp is equal to null. So this condition is false. Okay, so this is the way through which we can display the element of linked list using queue. Okay. Next one is finding the peak element of the queue. So how can we find out the peak element? So we know that the front element is basically the peak element. So first of all we check that the list is empty or not using front and rear variable. So in this particular case front and rear are not equal, hence this F block will not execute it. Now we will move towards else block. The peak of queue is %d front to data. So front to data is what? 10. So that is the peak element in your linked list. So this is the way through which we can perform NQ, DQ, display, and finding the peak elements of the queue when the queue is implemented using linked list. Thank you so much. In our next lecture, we will discuss another concept. Thank you.